In this video, we're going to look at ratios and proportions. So the first thing we need to think about is, what is a ratio? A ratio is just a statement of how two quantities compare, or how two numbers compare. So let's think of an example having to do with school. Let's say that in a school there are 2 girls for every 3 boys. You can write this ratio in a couple different ways. One way that you might see it is you might see it as this: 2, then a colon, and 3. So 2 to 3 is the ratio of girls to boys. Another way that you might see this written is as a fraction. This is how we're going to use it in algebra. That would be 2 over 3. This compares the number of girls to the number of boys. This exact same relationship can be represented with another fraction. So the fraction 3 over 2 compares the number of boys to the number of girls in this school. Another thing to think about is that there is a third type of ratio you can look at in this situation, and that's going to be with the total number of students. So I have 2 girls for every 3 boys. How many students do I have total? I have 5 total students. So if we were going to look at the ratio of girls to total students, it would be 2 girls for every 5 students, or as a fraction, it would be 2 over 5. So this is the fraction that represents the girls out of the total number of students. You could also do this same thing with boys. So in this case, we have 3 boys. So the ratio 3 to 5 represents the ratio of boys to total. And that would be the fraction 3 over 5, which is boys and total. You want to keep that in mind when we're working through some proportion problems, because sometimes the ratio that you need to use isn't distinctly stated in the problem. Proportions come into play when you have 2 ratios that are equal to each other. So let's go back to our original proportion with girls and boys. We said that there were 2 girls for every 3 boys. Now, let's say there were 6 boys. How many girls would there be? 4. So 2 over 3 is the same as 4 over 6. That is a proportion, 2 ratios that are equal to each other. This could even add up even more. So let's say there were 20 girls. How many boys would there be? There would be 30 of them. All of these are equivalent to each other. We're going to be focusing on when there are 2 ratios that are equivalent to each other, because that represents a proportion. This is handy when solving. So if we knew that there were 2 girls for every 3 boys, and let's say I knew that at a certain school there were 150 boys, I want to find out how many girls there are. So I'm just looking for this bigger ratio. Since we know that this is a proportional relationship, we know that these 2 things are equal. This is also a ratio that represents girls and boys. Now, how are we going to solve this? We're going to solve this using a technique called cross multiplication. Cross multiplication means that you multiply the numerator of the first fraction by the denominator of the second fraction, and you multiply the denominator of the first fraction by the numerator of the second fraction. So let's think about what this would look like. 2 times 150 is 300. And then we also have 3 times g, which is 3g. Now our variable in this case is g, and we want to solve for g. Think back to your solving. What would you do to get g all by itself? You need to undo times by 3. So to undo that, we're going to divide by 3. So the number of girls in this situation is 100 girls, because 300 divided by 3 is 100. So the technique we just used was cross multiplication. I'll be drawing those circles a lot throughout this video to help you guys see exactly what cross multiplication is. Alright, so here's a problem. We know that the ratio of ducks to geese in a pond is 16 to 9. Let's rewrite that as a fraction so we can do some algebra with it. So 16 over 9 represents the ratio of ducks to geese. Now, let's say that we also know that there are 192 ducks in the whole pond. So if we wanted to solve this, we need to create another ratio to make a proportion. We know that there are 192 ducks in the whole pond. We need to find the number of geese. So we don't know the bottom of this second fraction. Notice how I've been writing out D and G, or before I wrote B and G for boys and girls. This is because that helps you remember what is in which part of the fractions. Your fractions need to contain the same information. Both of these fractions are ducks and geese, ducks and geese. So we can go ahead and we can solve this using that cross multiplication technique that I talked about earlier. So remember, cross multiplying means we're going to multiply these two, then we're going to multiply these two. So the first multiplication problem was 16 times g, and that's just 16g. The second multiplication is 9 times 192. You might need a calculator to do this. That was the pause time for you to actually do that yourself. Alright, the 9 times 192 is 1,728. Now it looks like we actually have an equation, and we can solve this. Think about, what am I going to do to undo 16 times g? I need to divide by 16. Divide both sides by 16, and we'll find the number of geese in this pond. So 1,728 divided by 16. I'm going to give you guys a second to do that. Alright, so how many geese are there? There are 108 geese in the pond. So here's another situation. We know that to make green paint, you need 3 pints of blue for every 5 pints of yellow. And a painter needs 40 pints of green. We need to figure out how much paint he needs. Now, right off the bat, it looks like 3 pints of blue for every 5 pints of yellow is our ratio. So that would be 3 over 5, and that would represent blue and yellow. Now, we know that our final product needs to be 40 pints of green. Well, if we go ahead and we write an equation, or a ratio, with 40 in it, let's say we were going to find yellow, this ratio actually has yellow and the total amount of green paint. So you can use T or G, whatever you want to use. Do our ratios contain the same information? No, they don't. So we cannot use this relationship. Now, let's think about this a little bit. We knew that there were 3 pints of blue for every 5 pints of yellow. How many pints of paint are there total in that relationship? It's 3 pints of blue, 5 pints of yellow means 8 pints total. So we can write a new ratio that's 8 on the bottom, and that gives us our total. Now, we know that there are 40 pints total for our painter. Let's find the blue first. We know that there are 3 blue for every 8 total, so there's the first ratio. We need to find the amount of blue, I'm going to use B to represent blue, there are in 40 pints. So now we have a ratio that represents blue and total and blue and total, so we can go ahead and we can use cross multiplication to solve this. So we need to multiply these two numbers, and that gets us 120. Multiply these two, and that gets us 8 times B, which is 8B. Now we have to do our undo step. We need to undo times by 8 to get our blue by itself. So we're going to do 120 divided by 8, and in this case that works out to be, that's your calculating time, 15 pints of blue. So we need 15 pints of blue. Does that totally answer the painter's problem though? we also need to know how much yellow he puts in. There's a couple different ways that you can do this. I'm going to write another proportion though. We know that there are 5 pints of yellow in our 8 total, so I'm going to write another ratio, 5/8. This represents yellow and total. The painter needs a total of 40 pints. So let's go ahead and let's find yellow. Our ratios represent the same information. We have yellow and total, yellow and total. We're going to use cross multiplying again. We're going to do 5 times 40, and we're going to do 8 times y. 5 times 40 is 200. 8 times y is 8y. Use our undo and divide both sides by 8. So 200 divided by 8 will get us our yellow. We need 25 pints of yellow. Ran out of space, so I didn't actually write out yellow. Now, you could have done this another way too. You knew you had 40 pints and 15 of them were blue. How much is left over for yellow? But I wanted to give you guys another chance to apply cross multiplication to a problem, which is why it looks like it did. Sometimes we end up with problems that are just irregular equations, but we can solve them using the same techniques you would use as solving ratio and proportion word problems. So let's look at this one. We have x plus 10/8 equals the number 12. Right now it's not a proportion because I don't have two ratios or fractions equal to each other. But let's think about that 12. Is there a way you can write 12 as a fraction? 12 is 12/1. If we write this way, we can use our cross multiplication to solve it. Cross multiplication means these two times these two. Alright, so we have 1 times the quantity x plus 10. 1 times x plus 10. Notice I'm putting it in parentheses because all of it was together, all of it gets multiplied by 1. Equals 8 times 12. That's 96. Now when I look at this equation that I need to solve, I need to use one of those other steps we talked about, which was distribution. We're going to distribute the 1 to both things in the parentheses. So we end up with 1x, or just x if you want, plus 1 times 10, which is 10, equals 96. Now we can undo. We need to undo plus 10, so we subtract 10 from both sides. We end up with 1x, or just x if you want, equals 86. The last step is to divide by 1, but what's 86 divided by 1? Still just 86. So for our final answer, we have x equals 86. This was an example of using cross multiplication to solve just a regular equation that didn't necessarily represent a proportion word problem. Here's another example. This one already has two ratios, so we don't need to change anything. Since we have one fraction or ratio equal to another fraction or ratio, we have our proportion and can use cross multiplication to solve. So, y plus 2 times 31 is the first thing we need to do. Then y plus 7 times 11 is the second thing. Remember in the last problem where we used parentheses? We're going to need to use parentheses again. 31 times the quantity y plus 2 is 31 parentheses y plus 2. 11 times y plus 7 is 11 parentheses y plus 7. We needed to put those parentheses in there because you can see we have to distribute now. We're going to distribute 31 on this side. It's 31y plus 31 times 2, 62. On the other side, the number we're distributing is 11, so we're going to distribute 11 to both terms. So we get 11y plus 11 times 7, which is 77. Now we're left with an equation with variables on both sides. Remember, with variables on both sides, you can't use your do and undo until you get them all together. So the first thing I'm going to do is move that 11y. I need to undo 11y from that side of the equation, so I need to do the opposite, which is minusing 11y. And since this is an equation, we also have to subtract 11y from the other side. So now we have 31y minus 11y, which is 20y, plus 62 equals 77. Alright, now we can go ahead and use our undo. We can undo 62, so we're going to subtract 62 from both sides. I'm going to move my answer over here. 62 minus 62 is 0, so we have 20y on that side. 77 minus 62 is 15, so we have 15 on that side. One last thing to do, we need to undo the times by 20. Divide both sides by 20. We have y left over on the left side, and 15 over 20. That doesn't divide out all that nicely, but it is a fraction that can be simplified. 15 over 20, they both have 5 in them, so we can simplify this by dividing out the 5. Dividing out the 5 on the top gets me 3. Dividing out the 5 on the bottom gets me 4. So my answer is y equals 3/4, or if you prefer, that would be 0.75. I know, another example, but I'm trying to give you guys examples of all the different types of ratio and proportion problems that you might find so that you're prepared for any of them if they should come up in one of your problems during a project. So in this case, we're already set up with a proportion. We can go ahead and use cross multiplication. So we're going to do 4 times 5x first, and then we're going to do x plus 2 times 10. 4 times 5x. This one is kind of nice because I can just go ahead and multiply 4 and 5 and then get 20x. Don't need to worry about parentheses because 5x doesn't have a plus or minus sign with it. On the other side, we have 10 times the quantity x plus 2, so in this case we do need parentheses. Now if we draw our line down the equal sign, we can see that on the right hand side we need to distribute, so before we can do any undoing. When we distribute that 10, we're going to end up with 10x and 10 times 2, which is 20. We didn't need to do any distribution on the left-hand side, so that stays 20x. Now we can go ahead and move. I see I have x's on both sides. I'm going to undo the 10x. I'm going to move those to the other side. To undo positive 10x, we need to subtract 10x. Take them away. We don't want them there anymore. But because it's an equation, we also need to subtract 10x from that side. 20x's, take away 10x's, leaves us with 10x's. On the other side, they cancel out, and we're left with 20. One last step is to undo timesing by 10. Undo times by 10 by dividing by 10. So we get x equals 20 divided by 10, and whew, not a fraction this time. 20 divided by 10 is 2, so x equals 2. Before I left, I wanted to give you guys one last word problem to practice writing your own ratios and proportions. The exchange rate for pesos is approximately 1,000 pesos for every 80 US dollars. We want to find out how many pesos we can get for $200. So let's go ahead and let's write the obvious ratio first. 1,000 pesos for $80. Now again, I'm going to write, I have pesos on the top and I have dollars on the bottom. Now I want to know how many pesos I can get for $200. So dollars was on the bottom, I'm going to write another ratio with dollars on the bottom. My 200 goes down there. I don't know the number of pesos, so that's going to be my P, and that goes on top. Now before you can say this is a proportion, you have to make sure you have the same thing. Pesos and dollars, pesos and dollars. We're good, so I can set these equal to each other. Now we're going to use our cross multiplication to go ahead and solve it. Remember, 1,000 times 200 is the first thing we want to do, and 80 times p is the second thing we want to do. 1,000 times 200 is 200,000. 80 times p, that's the easy one, it's just 80p. Alright, there's only one last thing we need to do, and that's need to apply our undo method. We need to undo timesing by 80, so I'm going to divide by 80, both sides of the equation. So 80 over 80 is nothing. That means I'm going to get pesos as my final answer. So you need to do 200,000 divided by 80, and that should get you your number of pesos. Calculating time. 200,000 divided by 80 is 2,500. So approximately 2,500 pesos is what you would get on this particular day if you brought $200 to the exchange location. And that was ratios and proportions. Ratios is a relationship between two things, usually written as a fraction. Proportion is when you have two ratios that are equal to each other. These can get tricky, so you may want to look at this video once more or bookmark it somewhere so you can access it quickly when you start seeing these in your problems during projects.